Welcome back. As promised, we are going to introduce a new Python construct called conditionals, or if statements. And let me introduce this concept by way of an example. So imagine I ask you to write some code or an algorithm to compute the whole number of factors of a number. So let me just remind you what I mean by that. Whole number factors are numbers that evenly divide a number. So if I give you the number 42, the whole number factors are 1 and 42. That's obvious because those evenly divide 42. But 2, that's even. 3 evenly divides 42. 6 evenly divides 42, and so on and so forth. Okay? So all of these numbers are the whole number factors that for the number 42. So let's think through the algorithm for a second. Let's think through how would we do this. Well, basically the idea is I want to ask for each number inclusive between 1 and 42, or whatever number I'm specifying, is that a whole number divisor? Is that a whole number divisor? Is that a whole number divisor? So yes, yes, yes. 4, no. 5, no. 6, yes. So on and so forth. So you can sort of see a loop there. You should hear a loop. And one of the things you're going to get in the habit of when you think about the algorithm is thinking about the constructs you have. So right now we have loops and variables and functions, and we're very shortly going to have conditionals. So what do I want to do in that loop? On each iteration of the loop, I want to check each incremental number between 1 and 42. And we've already seen examples of that when we've counted down or when we've rotated something. So we sort of see the construct for that. But now I have a conditional I want to ask. So if this number evenly divides this number, then I want to do something, say just print the number. Okay? And we don't have that mechanism yet, and that's of course what we're going to introduce. All right, so let's look at the code that solves that whole number solution. All right, so let's start with two things. N is 42, so this is the number I'm querying. So this could be whatever you want. Okay? F is going to be the counter that goes from 1 to 42, and on each time of the loop that you can see right here, I'm simply going to check to see if F and then F plus 1 and then F plus 2 is a whole number divisor. Okay, so let's look at the code. So there's my initiation right there. Here's my while loop. So what am I doing here? I'm saying while F, that's 1 initially, is less than or equal to N. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 42. And once I hit 42, I do one more iteration of the loop. Be careful with the edge cases there. And then I'm out. Remember, again, you've got the colon on the while loop. And look at the code here. All of this is embedded and indented by a tab. So that's the body of the loop. I'll get to that line in a second. And this is outside of the loop. So you got to look carefully at the indentation. This gets evaluated when the loop is done, and in particular when F takes on the value of N. This, of course, is the body of the while loop. And now let's break that down a little bit. Let's do this first. So I just want to remind you again that after the body is evaluated, this line of code gets evaluated because it is outside of the while loop. All right, so let's go back to the body, and here is my conditional construct. If, there's the keyword if, some conditional, colon, indentation, body of the conditional. That should sound really familiar. That sounds, in fact, an awful lot like a while loop. We have the keyword while. We have a conditional that evaluates to a Boolean. We have a colon operator, and then a body that is indented. So conditionals are the same thing. The difference is that you evaluate this condition the same way you evaluate the conditional on a Boolean. And if it is true, and I'll get back to specifically what we're doing here, you evaluate the body, but now you only evaluate it once. It's not a while loop. You're not iterating. You're simply saying, if this is true, do this. And if it's not true, just move on with your life. So in this case, this is the body of the loop of the conditional right here. So if it's true, I evaluate this. And then I evaluate this, the statement here, the increment. If this is not true, I don't evaluate this, and I evaluate this. I just keep on evaluating. So think about this as sort of a, if it's true, I go off and do this and then go back. And if it's not true, I just go forward. Good. So the print statement is the usual. So if, I should say what this is right here. So what am I doing here? N, of course, is the number. I'm doing modular division. So go all the way back to one of the first lectures. That percent sign is modular division. What does modular division do again? I divide two numbers and I hand you back the remainder. So what does it mean for a number to be a whole number divisor? Is that the remainder is 0. So if the result of modular division is 0, there again is the equality test, then I know that it is a whole number, a factor. So 1, 2, 3, all when 42 divided by those numbers, the remainder will be identically 0, and then I'm going to print f is a factor of n. And notice again that I'm doing string concatenation here. That's my is a factor string. So I have to convert f, which is the number I'm currently checking to see if it's a whole factor, and then n I have to convert as well. So on the first iteration of this, the conditional will be true because 42 mod 1 is equal to 0. It'll convert 1 to a string. It'll convert 42 to a string, and it'll print 1 is a factor of 42. And then when that's done, what will it do is it will increment f. So we have finished testing 1. We now want to test 2. So increment f by 1, and now I'm at the last line of the body of the while loop. Again, be careful with that indentation. I go back up. Is 2 less than or equal to n? Sure. Do it all over again. So here again you see the power of that looping construct, that these 2 lines of code are what I want to keep evaluating, and the only thing I want to change is the value of f here and here, and that's of course being done in the increment here, and I do all f until I get to 42. And I loop, 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 loop. Okay, so that's the new construct, the conditional. It says please evaluate this if a certain condition holds true. And it's very similar to a while, except it's just not a looping construct. It doesn't do it over and over again. It just does it once. Okay, good. So let's dive a little bit more into that into that conditional, because there's a couple of variants of this that we're going to want to see. All right, here's another simple conditional with an else clause. So this is a little new. So let's see what we're doing here. I have a variable temperature equal to 72. I'm asking if temperature is less than or equal to 32, colon, indent. This is the body of the conditional. If this condition is true, I will evaluate the entire body, in which case I will print it is freezing. Okay? Now, notice here that this is an optional, and you know it's optional because on the last example I didn't have one. It's an optional else statement. So let me just show you what we're doing here. So if is the key word, else is a key word. There's the colon, there's the indentation, there's a body. So both the if clause and the else clause have the same structure, colon, indentation, body. And the way to read this if-else statement is, if this is true, then do this. And if it is not true, then do this. Okay, so what will happen is, and this happens top to bottom, I evaluate this conditional. Is it true? Yes. I print it's freezing, and then I'm out. If it is not true, I go down 1, I look at the else statement, and I say, I must have to evaluate this. It's not so cold. So in this example with temperature 72, this expression will evaluate to false. I'll come into the else clause, and I'll automatically say it's not so close. So if statements, as you saw on the previous slide, can be just do this if this is true, or you can have a catch, which is it's this, else do this. And again, that's optional. You don't have to have an else clause. Okay. So I think I'm just going to walk you through here, so let me go ahead and just skip over that part now. Okay. So now let me go through the third variant of an if, which is called an if-elif ladder. Okay, so this has now the part we've already seen, the if clause, the part we've already seen, the else clause, and what's going to happen now is we're going to walk through this if-elif in the following way. All right, set the temperature equal to 72, and we go to the first line of the if-elif ladder, and we say, if this is true, then print freezing, and then get out. You're done. Because nothing else matters. This takes priority. However, if it's not true, then please come in and now don't by default, this isn't an else statement, don't by default evaluate this conditional. So check if temperature is less than or equal to 50, and if it is, print it's cool, and then get out. You're done. And if it's not true, then go down to the next elif, check this one, if it is true, print it, and then get out, and then finally, if none of these statements are true, if it's not less than or equal to 32, and it's not less than or equal to 50, and it's not less than or equal to 75, then just go ahead and do this. There's nothing to check. So what's important with these if-elif ladders is that they are evaluated top to bottom. If any single condition evaluates to true, you are done evaluating the if-elif ladder. There's no more work to be done. Only one of these lines of code, one of these print statements, can be evaluated depending on, of course, in this case, what the value of temperature is. All right, let's see a more concrete example of this because there's some interesting sort of side effects here. So let's look at this. First of all, notice I have an if-elif, and by the way, notice I can have a variable number, including 0, elif ladders. So I can have an if statement with only an if. I can have an if and an else. I can have an if and a bunch of elifs and an else, or I can have an if and a bunch of elifs and no else. So everything after the if statement is optional, and it just depends on what you need. It depends on what the logic is of your underlying code. So let's look at this example. I'm initializing a variable x equal to be 1. I'm asking if x is greater than 0, then please print positive, and then multiply x by a negative 1, so negate it. Okay? And then I'm saying, okay, if x is less than 0, then print negative, else print 0. Okay? All right, so if this line of code wasn't here, right here, this negation, this would just be like something fairly simple. It's simply telling me if x is positive, negative, or 0. So let's just walk through that first, and I'll come back to this line of code in a minute. So if x is equal to 1, what happens? I say x is greater than 0, sure. Print positive, I'm done. I'm done evaluating this if-elif clause, and I go to this line of code right here, and it prints x. Now, if x was negative 1, this would evaluate to false, so I would drop down to this elif. X is less than 0, I'd print negative, and I'm done. I drop to this line of code because, of course, this is outside of the body of the if-elif ladder. And if x is 0, this is false, and then by default, this must be true. I don't even have to test if it's equal to 0 because it's the only other possibility. I print this, and then I print one line of code. Okay, now let's look at this particular example here, and let's see what happens. Okay, so x is equal to 1. We evaluate that. That's easy. That's just an assignment. I come in and I test that little expression there. It's a Boolean expression that evaluates to true or false. Of course, 1 is greater than 0, so we're going to go ahead and evaluate the body of the code of the if statement. So let's go ahead and do that. It prints positive, which is what you see right down there. Good. All right, we've got positive, and now we go to the next line of code of the body. X is equal to negative 1 times x. So what am I doing here? I'm taking the current value of x, and then I'm going to negate it, multiply by negative 1, and then reassign it to x. So at this point, x is negative 1. Okay? Now the question is what happens next. So here I am in the body of the if. X is equal to negative 1. And what happens next? So think about it for a second. All right, so if you said that I then print negative, that is unfortunately incorrect, and here's why. It is true, you are absolutely right that x is negative, but even though x is negative, I don't evaluate this conditional. Why? Because once I evaluate this, and it's true, none of these other clauses can happen, despite the fact that I've changed the value of x, completely irrelevant. Right? So at this point, what's going to happen is I have decided in this if-elif ladder which clause gets evaluated, and only one of these clauses, one and only one clause can be evaluated. So at this point, I dive down to the last line of the code outside of the if-elif ladder, and I print x, which of course is negative 1. Good. Conditionals. Okay? So conditionals allow us to evaluate code when certain conditions are true. And they allow us to stack up through this if, elif, else ladder what we want to do under what conditions. Okay, and we're going to see lots of examples of that in the coming weeks. Let me emphasize again what's important here. If statements have a conditional that evaluates to a Boolean, it has a colon and a body. If that conditional evaluates to true, you evaluate the body. Very much like a while loop, but without the iteration. Optionally, you can have an elif ladder with one or more elifs, or 0, 1 or more elifs. And optionally, you can have an else, but only one else statement. And of course, that makes sense, because I can't say else do this, else do this, else do this. The else is the catch-all, that you failed all the conditions from top to bottom, and this is what you're going to do no matter what, because this is where you've landed. Okay? And again, in an elif ladder, if elif ladder, just as you saw, only one of those clauses can be evaluated, and you evaluate them from top to bottom so there's a priority. What's the right thing to do? How do you do it? It depends on the logic of your code. We're going to see lots of examples of that in the coming weeks. All right, so I'm going to stop here, and in the last part of this lecture, we're going to do a series of drills, that pulsating circle that we promised, and now we're going to bring in the conditional because that's what we need to solve that solution. So I'll see you in a few minutes.